So when we calculate average atomic mass, the important thing to remember is that this is a weighted average, right? Normally when you find the average of something, you just add up all of whatever it is that you're finding, like, if you're finding the average mass, you just add up all the masses and divide by how many there are. The difference here, though, is that you have to account for the abundance of each isotope in an element. All right, so let's look at this example. We have 3 isotopes of silicon. We're given the mass information of each isotope, and we're given the fractional, or the percent abundance of it. Normally you'll be given this in percent. We can ignore the fact that it says fractional. So the very first step you want to do is divide each of your percent abundances by 100. Get it back out of a percent. Then we can actually use it. That's the same as moving the decimal over 2 to the left. So the first one's going to be 0.9221. The second one is 0.0470. And the third one is 0.0309. Right? Then we want to multiply this is now called the relative abundance. When we divide the percent abundance by 100, it becomes the relative abundance. We're going to multiply the relative abundance by each mass. So, and then we do that for each isotope. So we're going to take 27.977 times 0.9221. That gets us 25.80. We're going to use 4 sig figs because that's the lowest one in the problem. The next one is 28.976 times 0.0470. That gets us 1.36. 3 sig figs because 0.0470 has 3 sig figs. And then the last one is 29.974 times 0.0309. And that gets us 0.926. The third step is we're just going to add together all of our relative masses, the products from multiplying the mass by the by the relative abundance. So we're just going to add all those up. 0.926. All right, and that gets us 28.09. We only can have significant figures to the second decimal place, so that's where we get to stop. And the unit is AMU. All right, that's the unit for atomic mass. It stands for atomic mass unit. And this is our final answer. So that's the basics of doing average atomic mass. Notice we didn't just add up the masses and divide by 3. We have to account for the percent abundance. Now, a couple helpful hints. Your average atomic mass will be within the range of your masses in the problem. Like 28.09 cannot be lower than 27.977 or higher than 29.974. It is mathematically impossible to have an average that is lower or higher than any of your numbers. It can't be lower than the smallest number or higher than the largest number. It's mathematically impossible. So if that happens, you've done something wrong. Also, you can make predictions about what your answer should be close to or similar to. For example, silicon-28, our first isotope in this problem, it has a percent abundance of 92.21%. It's making up the majority of our mass. So our answer should be closest to 27.977, and 28.09 is pretty close to that. All right, so look at the problems, make it mathematically make sense, go through the steps, and you'll be fine.